Analytical reasoning questions assess students' or candidates' ability to use critical thinking and logical reasoning skills. Uh, these questions typically have answers that aren't obvious, so answering them shows an ability to determine logical solutions. Usually, these problems are related to counting of geometrical figures in a given complete figure. So usually they are objective type questions. Here I'm just taking few questions and I just tell you how to solve such problems. First problem is count the number of squares in the given diagram. Okay, here there is a diagram. I just name this, say A, B, C and D. Okay, corner points I'm naming. Okay, one way of solving this is giving the names to the points, each coordinate points, and then counting the figures. Okay, here this is a complete square, and in the square there are few more, and I want to count how many squares are there. Okay, basically we can count the number of squares, basic squares: 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, these are the squares inside A, B, C. Okay, so basic squares, say basic squares, how many are there? 9 are there. Okay, okay, these are of each unit. Okay, I'm considering one single square, so that there are 9 such. Now what I do is I'll take 4 together, like 1, 2, 4, 5. So when I consider 4 unit squares together, I'm getting another square. Okay, this is one square when I consider all 4 squares together. Okay, so 4 squares together, if I consider, then how many squares I'm going to get? This is 1 by taking 1, 2, 4, 5. Then if I consider 2, 3, 5, 6, then I'm going to get one more. And then I can even take 4, 5, 7, 8, so 3 more, then last one 5, 6, 8, 9. So there are 4 more when I consider 4 squares together. All together, like I have all 9 squares. So when I consider 9 squares together, I'm getting 1 square. So total number of squares will be individual unit squares. There are 9. And when I consider 4 squares together, like 1, 2, 4, 5 or 2, 3, 5, 6, I'm going to get 4 more. And all together, like 9 squares together, they form a square A, B, C, D. So there are 14 squares altogether. So number of squares in the given figure is 14. Next question, how many triangles are there in the given figure? Okay, A, B, C, D, E and F. Basic triangles, if you consider 1, 2, 3 and the center 1, 4. Okay, basic triangles, number of triangles are 4. Okay, and one more I can consider by taking all 1, 2, 3, 4 together. So triangle ABC I can consider. So total there are 5 triangles in the given figure. This is the quite easier one. Okay, here is one more. You have to count the number of triangles in this. So best way to solve this is giving names to the vertices. I'm taking the center as, say, as O. Okay. Now we'll go for naming, listing out, or you can just directly write the names inside the triangle. Okay. So when I consider single unit triangles, there are 1, 2, 3, 4, 5, 6, right? Single unit triangles. There are 6. Okay. Now when I consider two triangles together, there are how many? 1, 2 together. So this is 1. Okay. Then if I consider uh, this 1 and 3 together, 1 and 3 together 2, 2 and 4 together 3. So there are, when I consider two triangles together, there I'll get 3 triangles. And then I'll consider this 1, 3 and 5. This 1, 3 and 5. So this is one triangle. Okay, and then I can even consider 2, 4, 6, these all 3 together. So that 3 triangle together, I'm getting 2 such triangles. 1, 3, 5, 2, 4, 6. So, and then I need to consider entire triangle now. That is ABC triangle, ABC. So there is one. So here when I consider two triangles together, 1, 2, 1, then 1, 3, 2, then 3, 4 together will get 3 triangles, and then last 4, 2 together, so that it is 3 plus 1. So total number of triangles will be 13. At that time I didn't count this 2, 4. So 1, 2 together one triangle, 1, 3, 1. So 2, then 3, 4, 1, 3. Then 4 and 2 together will form one more. So that is two triangles together. There will be 4 such triangles. So number of triangles in the given figure will be 13. And here is quite different one. Here also you are supposed to count the number of triangles. Count the number of triangles. Okay. Here I'm going to name the vertices, say A, B, C, D, E, F, and say I'm giving the names for these midpoints, say P and Q. Okay, now first thing is I have to split this. I just have to consider the triangular part, that is ABC. First I'll consider this ABC. Okay, this ABC has how many triangles? So you consider this. I'll just draw over here. Okay, A, B and C. There is an intersection here and there is an intersection over here. Okay, now when I have to consider number of triangles in this, one triangle is ABC itself. Okay, and say this point I know Q, and let me take it as say L and M. Okay, now another triangle will be ALQ, and another one will be AMB, AMB, and I have ABC also. Okay, and then I have MBC also. Therefore, this ABC has 4 triangles. Okay, this is first point. And second part, when I consider this ADC, okay, even ADC has 4 triangles. You can cross check just this part. I have A, D and C. There is a partition over here, say that is P, and one more somewhere here. Okay, this point I don't know, I'll just take it as X and Y. Okay, now You count the number of triangles here. ADX is 1, and then ADC is another 1. Then you consider this XDC, XDC, and then YPC, YPC. This is one triangle, this is one triangle, and all these two together one triangle, and all three together one triangle. Therefore, four triangles in ABC and ADC. Now, I just have to count the number of triangles in entire ABCD rectangle. Okay, so number of triangles in ABCD. So when I consider here, see, this alone, this part ABC alone has four triangles, and ADC has four more triangles, and when I club them together I can observe the triangle like BCP and ADQ, right? ADQ, and I can even consider BCP. So the total number of triangles in ABCD will be 10. Now I have to consider entire figure which has four more extra. That is, one is AED, triangle AED, and then BCF. Then when I club this triangle AED with the parallel with the rectangle ABCD, so that I'm getting AEC. AEC as one triangle, and triangle BCF with the rectangle, it makes BPF. BPF. So there are four more. Right. So total number of triangles in the given figure will be this 10 plus 4. 10 plus 4. So there are 14 triangles in the given figure. This is like quite confusing. So we are partitioning the diagram into parts, like taking ABC as one triangle, ADC as one triangle. Initially we count the number of triangles in them and then club together and find the number of triangles in the rectangle ABCD. And the last part we are considering AED and BCF along with the rectangle. Okay, so here is one more question. Here you are supposed to find the number of triangles. Same here. Number of triangles. Okay. So for that, what we are doing is, first initially we are naming the vertices. Say A, B, C, D, E, F, G, H, I, J, then K, L, M, N, and O. Okay, so first thing what we have to do is we have to start counting the number of triangles from each vertices. So like from A, then from B and C, then from D, E, F, G, H, I, J, like that. Okay, so initially first part from A will count number of triangles, or I can say number of triangles possible from point A. Number of triangles possible from point A. Okay, just count, that is only one triangle, that is ABC. Okay, that is in this level. So it is ABC is one, then ADF is another one, then AGH is the third one, and the entire triangle AKO. You can name it or you can directly write 4. If you want, I'll name ABC, ADF, AGJ and AKO. Okay, so there are 4 triangles from point A. Similarly, I'll count number of triangles from point B. Okay, from here one triangle is BDE. I'm direct. I'm taking directed triangles, not the inverted one. The uh, very first one will be BDE. Then I can say BGI, and then I can even say BKN. So there are 3 triangles. If you want, I'll name BDE. I'm not considering inverted ones. Some direct triangles I'm considering. BDE and then BGI and BKM. Sorry, BKN. BKN. So similarly from the point C, again I'm going to get 3 triangles. See, CEF, CHJ and CLO. Okay. Now we'll go for the next level, that is number of triangles from the point D. Okay, these are direct triangles DGH and then DKM. So 2 triangles DGH and DKM. So from all these vertices DEF, from this level, in this level DEF, they share two triangles. Okay, so even this is from D, from E also I'm going to get 2 triangles, and from F also I'm going to get 2 triangles. Okay, I'm not going to name all this. Okay, now we'll go for the last level, that is GHI. So number of triangles from G, H, I and J. They share only one triangle in every set. Okay, because see, this is this level GKL. I'm considering direct triangles, not the inverted ones. So GKL, HLM, IMN and JNO. So 1 from each, so there are 4. Okay. Now we'll go for counting the number of inverted triangles. So from first thing from LMN I have to consider. So from L, see, inverted triangles means will this way, will go by this way. Okay, so this is one such triangle. I'll take some other color, say this one. So this is one such triangle, and this is although, so another one, and from this one more. Okay, and then I'm considering inverted ones, so this one and this one and then this one. So I'm going to get from LMN, I'm considering 4, then LMN, and then 3 more, that is DHE, the inverted one, and EIF, and DFM, that is DFM together, DFM. Okay, so there are from L, M and N, I'm getting 4, and 3 more, that is D, H, E, then EIF, and DFM. Okay, so all together, say here I got 4 plus 3, 7, 10, 12, 14, 16 plus 4. So I got 20 plus 4 plus 3. So total there are 27 triangles in the given figure. Okay. Here there is one more approach for this, particularly when you have such graphs. There is one more approach to solve by using the formula. Okay, so what they do is they consider the partitions here, number of partitions or the number of triangles. Since they have asked for number of triangles, you can observe that each side has same number of triangles, 1 2 3 4. Here also 1 2 3 4, and here also 1 2 3 4. So each side has same number of triangles. If I consider n as number of triangles in each side, if it is same, okay, then I'm using the formula for counting the number of triangles, that is equal to n into n plus 2 into 2n plus 1 by 8. Okay, here in this case n is 4, so directly I can substitute here 4 into 4 plus 2, that is 6, into 4 into 2 8, 8 plus 1 is 9 by 8, so that I'm getting 2 then 6 3 9 into 3 is 27. So the number of triangles will be 27. This formula you can apply if it is asked for multiple choice questions. Otherwise, you have to go by this method. Okay, and this formula works only for this problem, not every time. If number of partitions are same in the given triangle especially, then only you can go for this formula. Okay, thank you.